Hello class, we are group 1 and today we will be presenting on integration and system testing.
Our presentation this week is about integration testing and system testing. There are important tests to do in software design because of the fact that software tends to be made of many different modules. It's easy to get an individual module by itself working and then test it using unit testing. But that does not necessarily mean that multiple different modules will work together well, or that the system as a whole will function once everything is put together. Integration testing is the process of testing whether modules will collectively perform the correct function when they are put together. System testing is the process of testing the whole system at once to ensure that all the modules together perform the correct function. These two testing activities ensure that a modular application works correctly once everything is put together. There's often times in a project when you can have many of the individual modules working correctly, or so it would seem, but when you put it together they fail, that they don't play well with each other, and so you'd use integration testing to look out for that. And system testing is just testing the whole system, because often there's aspects to it that aren't even related to the modules that you're creating, such as details of the system architecture or facets of the environment. And so integration testing and system testing are designed to deal with those and help catch those errors.
When systems use Docker to manage the various modules and containers, it becomes necessary to ensure that the separate modules work together properly and the system performs as a whole. To facilitate this integration and testing phase, tools have been developed to ensure that the process is consistent, easy, and repeatable. One such tool for Docker is Test Container, a series of test containers for a variety of types of modules that are used to drop in and test that particular module.
Hi, my name is Robert Jones, and I'm going to be talking about the upsides of the integration and system testing. Number one is very time efficient. It's a very fast testing process, and once the programmer has written the integration test, it becomes very efficient to test your program for connectivity or communication or any other issues. Basically, it improves the speed of end-to-end testing. Usually, they're able to test the code base in a couple of commands depending on how their project is configured. That's kind of a segue into the number two, which is high code coverage. Basically, if the programmer has written out tests for every single module or component in their code base, it becomes very easy to test. Just at a click of a button, really, you can. So if you're making new code and you're implementing something new, you can rest assured knowing that your code is covered and that if something breaks, you will see it. You will see the test fail. And number three is detecting bugs early. Due to the relatively fast testing process and high code coverage, software engineers are able to detect bugs and breaks in the system early, which means that they can apply fixes to them swiftly. So if something does break, you will have a complete log, exactly where it broke, which test failed, which improves speed, and it ultimately saves money.
Hello, my name is Kyle Mueller, and I will be presenting on the downsides of system and integration testing. System testing, also known as unit testing, is considered by many to be unnecessary, and it is often overlooked. However, this can have a detrimental effect on the quality of a project, as system testing is cheap and easy, and can help to reduce undesired behavior in a piece of software. On the other hand, integration testing is slower than system testing. Integration testing also requires an experienced testing team and can end up being more expensive than system testing in the long run. Despite their strengths and weaknesses, it's typically best to utilize both system testing and integration testing, as they can be used as complementary tools to ensure a high level of software quality. In this slide, I will expound upon the effectiveness of system testing and integration testing. System testing and integration testing can both be extremely useful in the testing process when applied properly. Seeing as system testing and integration testing are so unique, certain kinds of projects work best when paired with different combinations of the two. System testing is the more versatile of the two, as it is cheap and does not require an experienced team of testers. System testing can be used for virtually any project. On the other hand, integration testing is more expensive and requires an experienced team of testers. Integration testing is best suited for large and complex problems that require further testing. Notwithstanding, system testing and integration testing work best when used together. Using system testing and integration testing as complementary tools helps to ensure a higher level of software quality. This slide shows the works we cited for this presentation. This has been Integration and System Testing by Group 1. Thanks for watching.